is Goddess of Science Physics. I'm Mrs. Bolvin, and this is the second part of our About Science series. This one talks about the scientific method. So, scientific methods are a series of steps used to gain, organize, and apply new knowledge. You use them all, people get like, oh, scientific method, oh, I'm so scared. It's not really scary. You use it all the time. Scientific method was actually credited to the two guys that you see in the pictures down below. The first one, A, is Galileo, who was kind of a big, huge, hairy deal. He was an Italian physicist about the time of the Renaissance. Galileo, just to let you know, had a little bit of time on his hands because he made the Pope angry, and the Pope was kind of in charge of Italy at the time, and the Pope said, well, you can't leave your house for the rest of your life. So he was on house arrest. So he had a lot of time to think about stuff. The other guy that's here with the jaunty hat and the ruffle around his throat is Sir Francis Bacon. He was an English philosopher. And you're like, what would a philosopher be doing with science stuff? Well, back then they were really intertwined together. So Galileo and Bacon kind of came up with the parts of the scientific method. They didn't really work together at all, but they have been credited with putting together these steps. Okay, so the first step, scientific method generally includes some, if not all, of the following. It doesn't have to happen exactly in this order, doesn't have to have all of the steps, but these are kind of the biggies that most scientists use when they're trying to solve a problem or find an explanation for something. The first one is recognize a problem. You need to observe the world and recognize a problem or something that needs explaining. You have done this yourself in your everyday life. Probably at some point you came into a dark room, flipped the switch on the wall and to light up the room, and the light didn't go on. You recognize the problem. Hey, it's dark in here. I need some light so I don't trip over the furniture. So you flipped a switch, so the light didn't come on, you recognize the problem. The second thing that you do is you're like, hey, let's make an educated guess. And because scientists always have like a special word for every God-blessed thing, an educated guess is a hypothesis. But you probably knew that. Probably as long as you were, from the time you were knee-high to a grasshopper, somebody would say, what's a hypothesis? And you would very proudly step forward and say, oh, it's an educated guess. But what does that really mean? Does it mean it's a guess that went to school? Probably not. What it means is it's a possible explanation based on something that some information that you had in the past. Maybe at some point in the past you had flipped a switch and the light bulb had been burned out. You changed the light bulb and that solved the problem. So you're using that prior knowledge to make a guess about what the problem is in this situation and how to solve it. When scientists do this, it's not that they personally have to have the knowledge themselves, although that does play a big role. A lot of times they do a lot of really in-depth research of other people's work in a particular field. So that can count as prior knowledge, even though they themselves didn't make those discoveries. So a hypothesis is a possible explanation based on prior knowledge. So your prior knowledge here is, oh, this has happened before, the bulb must be burned out. So what do? You predict the consequences of the hypothesis. Well, if I change the bulb, then the light will work. If I change the bulb, the light will turn on. Awesome. So that's predicting the consequence of the hypothesis. So you've kind of set up the parameters for a little experiment that you're going to do. And guess what the next thing is? Perform experiments to test the prediction. So you think that it's the light bulb that's burned out. So what are you going to do to test that prediction? You're going to change the light bulb. So you go and get a light bulb and you flip the switch again. So that's performing an experiment. And then, based on the results that you get, you formulate the simplest general rule that organizes the hypothesis, the prediction, and the experimental outcome. I thought that the lights wouldn't go on because the light bulb was burned out. And I changed the light bulb and it worked. The light didn't come on when I flipped the switch after changing the light bulb. That's another possible outcome. That's organizing the hypothesis, the prediction, and the outcome. Okay, so that's it for the scientific method. Thanks for joining me. Have a great day.